Apache Kafka is an open source distributed event streaming platform which is used for data pipelines as well as data integration. In this tutorial, we will learn how to set up Kafka on our machine using Docker, and then we will look at Kafka CLI, Control Center, REST Proxy, Kafka Connect, and Ksql as well. Let's start with the CP all-in-one repo provided by Confluent. For now, we'll be using CP all-in-one craft folder, which has a Docker compose file. And if we install Docker and then if we run Docker compose up, it will run all these services. Since I have already downloaded all these images, it will start the services quickly. But if you are running this for the first time, it will take some time. Once the cluster is up and running, we can go ahead and create a Kafka topic. So I'll be creating a Kafka topic called as demo, and it has created a demo topic. Now let's create a producer to produce some messages. So it will show us an interactive prompt. Here we can just send any messages that we want. Since we have not defined a schema here, we can send whatever message we want. It will be streamed as an array of bytes. And now we can also start a consumer which will consume messages from the same topic. So we can start a Kafka console consumer, and then it will consume from demo. And now if we go back to producer and send a bunch of messages, we can see the consumer is receiving the messages. But sometimes we want to consume all the messages from the beginning of the topic. So in such a case, we can pass additional flags saying offset as earliest. And if we run this command, we can see it is consuming all the messages from the beginning. We can also start multiple consumers, and if we send some messages, we can see both the consumers are receiving the message. Let's delete that demo topic and then recreate the topic with two partitions. So far we have produced just messages without any keys. Now let's use a key separator as well, so that we can send key and value pairs as a message. And if we start a group of consumers now, let's subscribe to the same topic, and let's name the group as demo. Okay, now let's send a few more messages, and we can see that these messages are getting distributed between both the consumers. Let's go back to the Docker compose files that we have used, and if we look at the services list, we have a service called the Control Center, which is running on port 9021. So we can go to localhost 9021, and we can see Confluent Control Center UI here, and we have the cluster here, and we can see bunch of statistics here. And if we go to topics, we can see the demo topic that we have created. It has two partitions, and it also has a bunch of config options. We can also modify them. By default, the retention time is 1 week. We can change that. There is also a limit on the retention size as well as the message size. We can save those. We can also create new topics, and then we can also produce and consume messages from here as well. If we look at messages, it will show the existing messages. We can see all the messages here. We can also click on produce message, and we can send messages from here as well. We can see the same message was sent to this consumer as well. And if we go to consumer groups, we can see the demo consumer group, which has two consumers consuming from a single topic. We can also see from which partition each consumer is consuming, and also the offsets of the consumer. So this is a brief overview of the Confluent Control Center UI. If we look at the Docker Compose file again, we are also running another service called REST Proxy, which is running on port 8082. So it exposes REST APIs, and we can do almost all the things that we have shown here via REST API as well. If we go back to Postman, and if we hit the topics endpoint, we should see all the topics that are available here. Uh, so we have a demo topic here, and we can also query for a single topic, which will return all the properties, the config properties of the topic. And we can similarly send messages to the same topic. I'm just sending a demo message here. It has returned a 200 OK response, and if we go back to terminal, we can see consumer has received the message. One of the main reasons Kafka got high adaptability is because of the connectors ecosystem. Kafka provides something called as Kafka Connect, where we have a bunch of connectors to pull and push data into various other systems like Redis, Elasticsearch, AWS S3, and so on. And if we look at our Docker Compose file, it is running on port 8083. So if we go back to Postman and do a get on the connectors, it is showing empty because there are no connectors right now. Kafka provides a demo connector called a DataGen connector, which generates some random data for page views, and then it will push into a Kafka topic. So we have a simple configuration here where it will be pushing messages to page views, and if we do a post on this endpoint, it will create a Kafka connector. And if we go back to Confluent UI, and then we can see there is the connector here, and it says it is running right now. And if we go back to the topics, and if we open the topic DataGen page views, and if we click on messages, we can see it has already generated 398 messages. Let's refresh the page, and then we can see there are almost like 570 messages. So it is generating a lot of messages here. This is just a demo connector. There is also a Confluent hub where we can see all the available connectors here. The last thing we will look at is KsqL. Kafka also provides an SQL interface so that we can write SQL queries to create streams and also tables. We already have this data gen page views topic where we have messages which contain user ID, page ID, and view time. Now let's go back to KsqlDB, and then let's create a simple stream from this particular topic. So I'll just run this query. It will create a stream from that particular topic. We can just run select star from page views stream, and it should show us all the messages that are coming into that particular topic. Now we can also create tables from this particular stream. Maybe we want to count how many page views are getting per page. So we can create a simple table like this, which has like page views count. And now we can also run the same query here. Select star from page views count, and then it will show us an aggregate view count for all the pages that are there. So if we just run it again, it will show the updated count. So this is a simple use case where we can run SQL queries against topics, streams, and tables. There are three kinds of queries that we can run in KsqlDB. One is persistent queries. Just we have seen how to create new streams and new tables, which will come under this section. Apart from that, there are also push queries and pull queries as well. I'll share a link for this below. You can explore further. So we have seen how to set up Kafka locally, and then various ways to interact with Kafka, and some of the useful tools that Kafka has. Thanks for watching. Stay tuned for more tutorials.